Hey everyone, good afternoon or good morning, depending on what time zone you are in. Welcome to APU Postgraduate Live Webinar. My name is Regine from APU and I'm your host for this session. We're having two sessions of live webinar today. The next session will be at 4 p.m. I would like to invite you to check out our Postgraduate e-Open Day that's happening since Friday. And today will be the last day for our e-Open Day. Our counselors are ready to guide you through all the study options, scholarships, and employability options with postgraduate study. For more information, please visit our website and follow our Facebook page. For this session, we'll be covering on the topic of evolutionary algorithms in the data science toolbox. The purpose of this session is to demonstration some simple problem solving AI algorithms which form part of the data scientist toolbox. Now, without further ado, I would like to introduce our speaker today, Dr. Imran Mehdi, Senior Lecturer in the Faculty of Computing, Engineering and Technology at APU.
Hello, can you hear me?
Hi.
Hello,
Over
Regine.
to you, Dr. Imran.
Clearly? Hello, Regine, can you hear me clearly?
Yes, it's very clear, Dr. Imran.
Thank you very much. Okay, let me just share my screen and then we'll make a start.
All right.
Okay, can you see my screen?
Yes, Dr. Imran.
Thank you very much. Okay then, so as Regine mentioned, my name is Imran. I wear two hats at APU. First and foremost, I'm a lecturer from the School of Computing. I teach at postgrad undergraduate level a variety of different things, including computational intelligence, which is kind of the topic area for this particular talk. In addition, I'm the program leader for the data science and business analytics program. So if you are interested in our DSBA program, then I'm more than happy to talk to you even after this particular session. We can have a little one-to-one if you like. Okay, but the topic for today is evolutionary algorithms from the data science toolbox. And the basic idea is that I'm going to go through a brief overview of data science. So this isn't really a talk about data science per se, but I'll just give a very brief introduction to data science and then introduce us to evolutionary algorithms, which is basically what we're here to listen to or talk about. And then run through a couple of examples of genetic algorithms and then contextualize this to data science. So how are these applicable or useful to data science or to the data scientist? Okay, so without much further ado, let's make a start. Sort of define data science. So I'm sure you've all heard of data science. So data science sits at the intersection between sort of three disciplines: mathematics and statistics, business, and computer science. And basically the idea with data science, there are a number of different definitions, but we can simply think of data science as a way of handling and manipulating data so as to gain new insights and new knowledge. So be able to make the unknown known through that exploration of our data. And data science has been hogging headlines for quite a while. In 2012, I think it was, Forbes magazine described data science as the sexiest career in the 21st century, which is hyperbole and hyperbole, but it has rung true in terms of the importance of data science. So there's been a lot of attention to data science. It is a discipline which is industry agnostic, and so it's applicable to a variety of different domains, ranging from medicine, health, government, the private sector, the public sector, and so forth. And there's been a lot of attention in this particular area with the COVID pandemic. If you've been keeping, I'm not sure if any of you are, but if you've been keeping track of sort of the UK government's regular briefings about the COVID situation in the UK, the mantra that they often repeat is the data will decide. And so basically data science techniques are being applied to help government plan for and decide how it's going to tackle the COVID-19 crisis. But so it's something that is well established and being used, and there's lots of growth and career opportunities in this particular area. And there's a number of reasons why, which I'll sort of flip to in the next slide. What we need to know, just basically for later on, is have an awareness of that data science process. So data science is a very broad concept, okay, in which we can sort of represent it as a series of stages. And so there are these 6 stages, starting from that aggregation of our data. So we have disparate data in different particular stored in different places, on databases, in the cloud, etc. And so that process of the aggregation, acquisition of this data, all the way then to the visualization and presentation of something through that interrogation of the data. So we need to go through this acquisition, through this data processing, integration, modeling, and so on and so forth. And all of this allows us to then do certain things. So there's key things that we can do through the data science discipline, which makes it particularly attractive to organizations and industries and different sectors. Okay, we can engage in descriptive analyses to find out what happened. From there, we can engage in diagnostic analyses to find out why something happened, and then engage in predictive analyses to find out what will happen. And ultimately then go through a process of going through prescriptive analyses to see, to help us to make decisions, better decisions. And so ultimately the aim is to help improve that decision-making process, whether we're in an organization or we're in government and so forth. Okay, so that's the basic idea, and that's what we're basically doing through data science, is following these particular stages, applying different methods, models, and so forth, statistical models, mathematic models, AI and machine learning models to basically help in that process of describing, diagnosing, predicting, and prescribing. Okay, so that's a very, very brief description of data science in a nutshell, a very small nutshell. The key thing we're here to talk about is evolutionary algorithms. So let's start off, first of all, by discussing what we mean by evolutionary algorithms, and what we actually mean by evolution. So evolutionary algorithms are based on the principles and concepts of this particular person over here. So here we have Charles Darwin. And Charles Darwin set about testing his hypotheses, embarked on an arduous journey on the HMS Beagle to the Galapagos Islands. And from the Galapagos Islands, he engaged in sort of island hopping, so he's the original island hopper, to basically observe the different flora and fauna that existed on these particular islands. And he noticed one particular thing that reinforced his hypotheses and his assumptions, and that is the changes in attributes of certain species from island to island. Okay, and so what he noticed was that certain birds, the same species of bird, had different physical characteristics and different physical attributes depending on where it lived and its environment. Okay, and this helped to cement his idea of natural selection. And so this concept of a population going through this evolutionary process of adaptation so as to be able to best adapt to its environment. And these ideas, okay, this particular concept was best observed in a species of moth called the peppermoth. Okay, so the peppermoth is found in quite a few places, but in particular, this group of moths existed or lived in England. Okay, so this is at the time of the Industrial Revolution. And so what peppermoths like to do is they like to sit on lichen. And lichen has a sort of a speckled black and white texture. And so the moths were particularly well adapted to sit and sort of chill on this lichen because of their coloration. And it made it very difficult for predators to actually eat these. So they were particularly successful in avoiding predation based on that particular adaptation of their particular environment. So the peppermoth was living a very nice life, okay, going from generation to generation until the advent of the Industrial Revolution. And so during the Industrial Revolution, what happened was you got lots of factories popping up, churning out lots of pollution and soot. And all of that soot and pollution that was sort of dispersed into the environment started to settle on these lichens. And so over time, the lichens got darker and darker as more and more soot covered them. And this resulted in these moths, which were before very, very successful in avoiding predation, suddenly standing out and being easy pickings for predators such as birds. And so there was a sudden and sharp decline in the population of peppermoths, okay, until it reached a particular point where the species was potentially endangered and possibly on the way to extinction. But something that scientists noticed was that over a series of generations, the population started to change. Okay, so through this process of pairing up, okay, parents, this mating process, or we refer to as crossover, with the potential introduction of mutation, and then the creation of a new generation, and this process repeating, the moths gradually started to change color. Okay, so this process of natural selection, of adaptation, okay, in which the genetic material of these individuals was getting crossed over or mixed up, resulted in this process of change to these particular moths. Okay, and things worked out quite well for the moths. So the population recovered. They were able to better hide and better blend into the black lichen. And what basically happened was the population recovered over time. Things are cool, no issues. But then we reached the end of that first industrial revolution. And so slowly by slowly, the environment started to recover, less pollution in the air, less soot, and the lichens started to change color again. Okay, so they started to return to the natural speckled color. And again, the moths stood out and population declined as their predation took place and they were being picked off by birds and other predators. But again, what happened was that process started to reverse. So over time, the population started to change. Okay, so we started to get lighter and lighter, more speckled individuals until eventually the entire population changed color and started to blend into this particular process. Now, this process, if we look at it in terms of we've got a population, okay, we go through this process of selection, individuals pair up, okay, they go through this process of mating or crossover, mutation would potentially happen, and then we get a new population and we iterate. Well, this kind of looks like an algorithm. And so this formed the basis, the inspiration behind the formulation of evolutionary algorithms in computational intelligence and in artificial intelligence. Okay, using this particular process, mimicking this biological process of evolution, whereby a population goes through this change from generation to generation, where the fittest individuals continue to spread their genetic material to the next generation, and so on and so forth. Through this particular process, a series of algorithms were developed that could be used for problem-solving purposes. Okay, so to just give us a bit of a definition of evolutionary algorithms, okay, I won't read those, I'll leave them there for you to read, but basically it's this concept of mimicking biological evolution, leveraging on that process of reproduction, combination of genetic material of individuals, mutation, to then arrive at a new population, okay, and repeating that particular process that can be used for potentially problem-solving purposes. And the idea is that the Darwinian survival of the fittest natural selection concept, whereby the best solutions to a problem perpetuate from generation, okay, or that information is passed to the next generation, and weaker generations are discarded, okay, or allowed to die out. So that's the basic idea. Okay, and so what we do with evolutionary algorithms is we can, if you think about the natural process, the natural evolution, if we go through this particular process of this algorithm, you've got individual parents, the mixing of their genetic material, of their chromosomes to produce new offspring. Okay, so these offspring take parts from parent A and parts from parent B to then end up with new genetic material. And then that process repeats itself. So what we can potentially do is we can feed in a chromosome into this particular algorithm. We can conceptualize our problem as a series of genes, a chromosome in total. We can make a population of chromosomes, and we can go through this process of evolution until, remember, it's survival of the fittest. So each time we iterate through this process, we get better individuals until such time as we arrive upon an optimized or best solution. Okay, and that's the basic idea with evolutionary algorithms. Okay, so we can look at this in a little bit more detail through an example. Okay, so what I've done here is I have an example that we use in our tutorial sessions with students who are learning about computational intelligence and evolutionary algorithms and genetic algorithms in particular. So here we have a scenario where, sort of hypothetical scenario, whereby the university APU is looking to schedule its security guard for its cyber security talent zone. Okay, so its state-of-the-art talent zone needs an appropriate level of protection and security. And so some rota or schedule needs to be identified for these particular guards. Okay, and there are some constraints placed on us in terms of the scheduling of this particular this rota or this schedule, okay, in terms of the number of shifts, okay, per day. Okay. And then there's some legal requirements in terms of ensuring that individuals have a certain break. There's constraints in terms of how many guards can work per day, how many guards we must have for each shift, and so on and so forth. And so this particular problem can be solved through an evolutionary algorithm, in this particular case, a genetic algorithm. And the way we do that is to conceptualize this problem as a chromosome. Okay, can we create a chromosome to represent this scenario? And this particular case, it's relatively straightforward. Okay, what we can do is there's three things or three layers that we're kind of interested in. We have days of the week. Within each day of our week, okay, we have some shifts, morning, afternoon, and night. And within each of those shifts, we're going to have a series of guards, okay, that are available, or a list of guards that we're going to be choosing from. So for every shift, we've got a list of guards that we can choose, and each shift or combine 3 shifts make up a day. And so if we flatten these lists, we can come up with what looks like a chromosome. In this particular case, a binary chromosome, but it can be denary, doesn't necessarily matter. Okay, it depends on the scenario. And when we look at that list, we can kind of identify components of that list. Okay, we've got guards represented at particular elements, particular points, and so placement of element represents, in this particular case, the 5th guard. And if we have a number of these together, okay, if we've got 16 guards, 16 of these collectively represents a shift. And so the next 16 would represent the next shift. And then if we have 3 of these shifts together, we can think of that as a day. So what we now have is thinking of that particular problem, representing it as a chromosome. Okay, so this is a particular chromosome that we can create, and we can pass this in to that particular process. Okay, so we can create a population of individuals. Each individual, okay, represents that particular problem or that solution, representation of our particular problem area. And we can apply our genetic algorithm process, the evolutionary algorithm, whereby we will select individuals. Okay, they will go through this crossover process. We can apply selective mutation. We can evaluate those individuals to arrive at a new population and keep on repeating this process. And as we go through this process, that chromosome, that solution that we have come up with, will get better and better until we arrive at an optimized solution. Okay, And we can evaluate that solution per iteration by putting in those constraints. Okay, so the number of shifts we must have, the break that's needed, the maximum number of shifts that each individual can have per week, and so on and so forth. So by passing all this information into our algorithm and mirroring that process of evolution, okay, we can potentially come up with a good solution, an acceptable solution, and refine it to make it a better solution. And so what we can do is, you'll see that there are these things here, this middle section is highlighted. We can selectively apply those genetic operators in terms of how we select individuals to be parents, how they cross over, how they go through that mating process, and how we then apply mutation before creating a new population. So there are a number of different genetic operators. So this is just some available through Python. So Python has a nice set of libraries available, the distributed evolutionary algorithms for Python, deep for short. So there are a number of different libraries in here that we can apply so as to be able to solve our particular problem. And tweaking these different parameters, you've got crossover, mutation, selection at the top there, can affect and improve the behavior and the performance of this particular algorithm. So let's have a look at this in action. Okay, so here I have some code. Okay, excuse me. Okay, and so you can ignore the code, the details, but what we have is we have coded up some of the information in that particular scenario. So we have some guards here. Okay, we have the minimum number of shifts and the maximum number of shifts and so on and so forth. All of that information coded up into here. We can then, if I scroll down, we can then apply some genetic operators. So we can think about the selection process. How are we going to select our individuals? Okay, we're going to think about that mating process in terms of how we're going to combine their genetic material. And we can think about mutation, the probability of mutation, and how that mutation takes place. And through this particular process, if I were to run this code, eventually, you can see that we're going from generation to generation to generation. Okay. This is the number of individuals that are being evaluated. These are the number of violations that we have, okay, per population. So violation of those constraints in terms of the number of individuals, the number of guards per shift, the frequency that each guard is working, and so forth. But through this process, eventually, okay, it's already finished, we can end up with a schedule for our guards. So in this particular case, I coded up 8 guards. Okay, there are no shift violations, so no guard is working 2 consecutive shifts. Okay, no guard is working more than 5 shifts. Okay, we have the appropriate number of guards on duty every day, morning, afternoon, and evening. Okay, so we have no violations. So those are our hard constraints. This is a tutorial problem that we address in our classes, and so there are additional constraints in terms of preferences for guards. So some guards don't want to work in the morning, and other guards don't want to work in the afternoon, and so forth. And so those have not been fully addressed. There are 5 violations. So of the number of guards that are working for the full week, 5 of them are working at a time that is not preferred. And so we can further tweak this and further tweak those genetic operators to improve upon this particular process. And what we can see down here is that those number of violations is decreasing, okay, per individual and as the population as a whole, till eventually at this particular point, after 40 generations, so iterating 40 times, we end up with our best solution in this particular case. Further tweaking may allow us to find a better solution. So what's happening here is that we are going through this process of selecting individuals, okay, through a particular approach. The approach that I chose there was tournament, whereby we pick 3 individuals and then we compare them, and the best one is chosen to be parent 1, and we repeat that process for parent 2. Once we have these individuals, we then combine their genetic material. So if you remember, that chromosome represents guards per shift per day, okay, for the entire week. And so we combine that to end up with a new individual. Okay. The key part here, the key thing is that we then apply mutation. Mutation adds that genetic variety. So instead of just mixing the existing genetic material of our population, we can add variation, and that allows us to balance what's referred to as exploration versus exploitation. Okay, if we think of this as a physical space, okay, that physical space containing all the possible solutions for this particular problem, we're searching this particular space to find the optimal solution. Okay, and so we want to explore it appropriately, but we also want to, in any particular area of that space, we want to exploit that as the best we can as well. So by balancing exploration and exploitation through mutation, we can achieve the best, potentially achieve the best of both worlds. And that's the basic idea with our genetic algorithms. And so through that process, we're able to solve that particular problem, a relatively simple problem, but one that demonstrates the capabilities of evolutionary algorithms, in this particular case, a genetic algorithm, to solve a particular problem. Genetic algorithms do two things quite well. One is optimization. So you provide a population of solutions, and it'll produce potentially a better optimized solution, as well as they have some benefits with regards to classification as well. Okay, so I have a link over here, and I'd like you to have a go. Not now, so just take a picture or just grab a quick copy of that link. And what that will do is it will lead you to this site over here. So I'll just give that 1 second. Okay, so that will take you to this bit of code I have here. And so what you'll need to do is you'll need to log in. This is Google Colab. You'll need to log in with your Google account, and then you'll have to click on this bit here, which is copy to your drive. Once you've done that, I've got a simple set of instructions here. So this is a classic optimization problem, sort of as the knapsack problem. And so you can think of this as a bag and knapsack or a backpack of fixed size. And what you're looking to do is you're looking to identify the best combination of items to put into this particular bag. Okay, so down here, okay, is a list of items. Okay, so we've got map, compass, water, sandwich, glucose, tin, banana, and apple. So what I'd like you to do later on, okay, we play around with this, is to add another 10 to 15 different items in there. Name of the item, the weight, and the value. Okay. And then what you can do is you can set the size of your bag. And if you run through this, what you'll see is it will give you various permutations or combinations of possible items, and then provide a list of the best optimal items to go into your bag so as to maximize the value and maximize the usage of that particular weight. Okay, and it's just another example of optimization problem using evolutionary algorithms. Okay, so the question then arises as to what's the relevance of all of this with regards to data science. Okay, so as I mentioned earlier, data science involves a series of processes, and these processes, particularly the first few of these, are quite arduous, particularly when it comes to actually going through that data wrangling process, that process of pre-processing and preparing that particular data. You've got disparate data sources in different represented in different ways, combining these and identifying the correct features or the correct attributes and deciding which of these to use for your model has implications on the performance of that particular model. And it's quite a difficult process. So one area that we can look at to leverage the strength of this optimizing capability of evolutionary algorithms is to apply genetic algorithms or evolutionary algorithms to that feature selection process. So what variables, if you think of a data set, if you think of Excel, for example, you've got columns at the top, which represent your various variables, possibly age, date of birth, gender, income, and so forth. So what combination or permutation of variables will produce the right result? For instance, if we're thinking about developing a model to determine whether a person is eligible for a loan or the extent to which they will default on that particular loan. So basically whether they should or shouldn't have been given a loan, then which of all the various attributes, features in our data set, which of those should we use to basically develop the most accurate model? Okay, so we can do that, and I'll give you an example shortly. Okay. Once we've actually developed that model, okay, we can then go through this process of tuning and improving the performance of that model, so hyperparameter tuning. And so evolutionary algorithms and computational approaches in general can be applied there. So when we're thinking about using neural networks and we're looking to optimize and decide the best number of layers within our neural network, we can utilize evolutionary algorithms to find the best permutation of layers to produce the best results for our particular model. So let's have a look at an example. Okay, so I'll zoom back over here. I have some code over here, and what we have here is code pertaining to a data set. Okay, and this data set is a list of animals in a zoo, and these particular animals have certain features, certain attributes, okay, variables related to them in terms of things like their habitat, what they eat, and so on and so forth. So is it possible to identify, okay, classify a type of animal based on these features? Okay. So if we were to feed in environment, diet, and so on and so forth, could we determine what type of animal it is? And if we just use sort of a classic solving approach and run this here, we'll see that this particular model here gives us an accuracy of 91%. So using all the features in our data set, okay, there's 16 features. So just plugging in all these 16 features into our algorithm, we can potentially identify what the animal is. There's a error rate of 10%, but it's accurate to 90%. Okay, so this process, in this case, we've just got 16, and we just dumped these into this particular algorithm. What if we had a lot more? Okay, and how do we know which of these would be best, and what permutation or combination could potentially give us a higher accuracy rate? Well, in this particular case, we can apply a genetic algorithm. And so I've run this before because it takes a little bit of time, but through tackling the same problem and applying a genetic algorithm, okay, we can see that we end up identifying what combination of features will give us the best result. So in this particular case, with the highest fitness of 0.96, okay, we'll see that, and an accuracy of 97, we just simply need to use 6 features, and these are the features that are identified. So from the data set, the the second variable, the fourth variable, the fifth variable, and so forth. Instead of just plugging in all 6, if we just select these particular variables, what we end up with is a better solution, which is more accurate. And so if we think of these in terms of error, one that gives us a 3% error compared to one that gives us a 10% error. Okay, so there is a lot of potential for the application of these evolutionary algorithms in this particular process of in different stages of that data science pipeline. And evolutionary algorithms work particularly well is in combination or as a complement to sort of your more traditional math, statistical, and machine learning approaches, but so as to optimize the results and the performance of those various models. Okay. There are other approaches as well within computational intelligence. So I teach computational intelligence, hence my interest. And so there are sort of 3 main branches. There are evolutionary algorithms, and so there are a variety of different algorithms available: genetic algorithms, cultural algorithms, and genetic programming. Cultural algorithms, all of these follow the evolutionary process. Cultural algorithms balance or look to evaluate two spaces. We have a solution space and we have a culture. And so we go through this evolutionary process of individuals, okay, changing the chromosome as we had in that previous example, as well as adapting and changing the culture, which has implications on those individuals. There's then swarm intelligence, which makes use of a lot of evolutionary concepts, but looks to introduce a degree of agency to each individual. So we can have a collective, a group of individuals. Each individual has a degree of agency to do certain things. And through that particular approach, we can arrive at identify optimal solutions. So there's particle swarm optimization, ant colony optimization, African buffalo optimization, a lot more bee colony optimization, cat swarm optimization, and so forth. Okay, and so there's a lot. If you are so inclined and you have a particular interest in nature, natural systems, you could potentially develop your own based on some phenomenon that you are interested in. And then finally, the most adaptive of all these three areas is artificial immune systems, which looks to mimic the learning and adaptive behavior of the human immune system. So the human immune system has an incredible capacity to learn from antigens that it encounters and develop antibodies so as to be able to then fight off that antigen in the future. And so there are various approaches for artificial immune systems, such as those based on danger theory and self, non-self. Okay, so there are a number of variety of different approaches available to data scientists from within computational intelligence to be able to optimize different aspects or areas of that data science pipeline. But at the end of the day, these are all just tools. Okay, so there are all approaches. The most important component in this is you, the human. Okay, it's the individual that must be able to leverage and understand that particular process, understand these particular algorithms, and leverage these algorithms most appropriately. And so that's where we sort of come in at APU. Okay, so we have, along the lines of this particular topic today, we have two particular programs that can help you to develop a career in one of these two particular areas. So data science and business analytics is our sort of well-established program. We were one amongst the first universities in Malaysia to spot the potential and the importance of data science, okay, and develop programs accordingly so as to be able to equip people with the necessary skill set. So we have programs at undergraduate and postgraduate level. Okay, our programs, the data science program has professional certification associated with it. So graduates, so people who complete the program, get a certificate from SAS and from TIDCO as well. Okay, as well as our AI program. It's relatively new, but it's the first top AI masters in Malaysia, so I'm led to believe, and it also comes with professional certification. Okay, so what we do, or what we aim to do with these programs, is to tap into your potential and unlock that potential and provide that nurturing environment so as to allow our graduates to embark in careers in this particular area. Okay, whether you're interested in data science and you're interested in that that pipeline, that process of data manipulation, gaining new insights from data and the various stages of that particular process, we look to equip you with the necessary capabilities and understanding of that process to be able to carve out a successful career in that particular area. Alternatively, whether you're interested in artificial intelligence and you're interested in things like fuzzy logic, image processing, computer vision, pattern recognition, computational intelligence, robotics, things like that, then we have a program for you as well, which is artificial intelligence. Okay, so we also have a dedicated research center, which is specializes in the area of analytics and AI as well to help support that. If you would like to know more about these two programs, okay, there's me again, my email. So I look after the data science and business analytics MSc. So you can reach out to me. You can speak to me today if you like. I'm available for discussions about that particular program. I teach on the AI program, so I can tell you a little bit about that. But that program is under my BFF, Dr. Chandra, who looks after that particular program. So she's the program leader for that particular program. So you can contact her if you have any particular queries about that, about data science, about AI. Okay, with that, I think I've reached the end. So thank you very much. Thank you for listening. Thank you for your time. And I'm happy to answer any questions that you may have.
Okay, thank you for your sharing, Dr. Imran. Now it's time for our Q&A session. So everyone, please feel free to drop your questions in the comment section here and we'll address to them accordingly. We already have we have one question here. How can data science possibly help to prevent another COVID-19 like outbreak? In the future, we will be able to forecast such pandemics and mitigate the risk related to it.
Well, that's a good question. Basically, the aim of data science is to basically learn from data. So data contains potential in terms of knowledge and understanding. So through the data that we are collecting. So if you think this pandemic is like unlike any other, partly because of the state of technology at this particular point in time. So we've all got the MySujetra app with us. We're scanning that app wherever we go when we venture out or brave enough to venture out. And so all the information about us is being aggregated where we go, who we meet with, and so on and so forth. And so all of this presents opportunities for data scientists, potentially like yourself in the future, to be able to conduct analyses and see what we can learn to be able to then potentially mitigate future outbreaks in terms of perhaps identifying the potential hotspots, potential individuals who may be certain risk, and so on and so forth. So it is an ongoing thing, and it requires a lot of effort to basically go through this particular process and leverage that particular data, and something which you could potentially, if you're so inclined, come to us, get your degree in data science, and contribute to as well. Okay.
Okay, thank you, Dr. Imran. We have another question here. So for example, choosing the best candidate for hiring, if only algorithm, then how to quantify human soft skills to make a hiring decision process? Will algorithm be able to do that?
As I think I mentioned, and I think as my learned colleague, Dr. Selvakumar, mentioned yesterday during his talk, these algorithms are not there to replace anyone. Okay, they're there to help with that decision-making process. So there could be some possible way of incorporating soft skills, an evaluation of soft skills. If we were, if, for example, in a genetic algorithm, if we were to provide certain weighting to certain soft skills, okay, as part of that fitness function, that evaluation function of an individual, as we go from one population to another, we could possibly integrate that in terms of evaluating an individual in terms of their sort of technical, I suppose, hard skills and soft skills. Whether we'd want to is a different matter, but it is feasible.
Okay, thank you. Let me see if we still have another questions. Right. Okay, now it's time for us to wrap up our session today, since we do not have any more questions. But of course, do reach out to us so that we can, provide you more information about the program, and also we can arrange a session for you to discuss with our academic expert. Okay. Sorry, Dr. Imran, before we leave, we have another question here by Sen. Are the algorithm that was covered in this talk already automating human scheduling system out there?
There are examples of the use of these particular algorithms. For example, Google makes use of genetic algorithms when it comes to Google Maps. So when you try and route these, lots of companies use them. For example, delivery companies, when it comes to routing packages. So you've got companies for a given day. Let's say it's got 1,000 packages. It's got that need to be delivered, and it's got 20 vehicles. Well, what packages should go where and how should these be delivered in what particular sequence. Genetic algorithms are used in that particular sense. So for a lot of scheduling problems, genetic algorithms are already being used, as well as specifically within data science, within that data science pipeline.
Okay, thank you. Right. AI or data science, which field has a bigger opportunity?
It's difficult to say. I think they are complementary in terms of how they relate to one another. I think data science is industry agnostic. It's applicable anywhere and everywhere. Okay, so there is potential. There's a lot of growth in that particular area as organizations that have the capacity and the capability, or that are investing in this particular area. They are looking to they need people to actually engage in the ends of these particular analytics and these particular analyses. However, data science makes use of AI concepts, so machine learning, deep learning, and so forth. So there need to be people to actually develop those concepts, those approaches, and come up with new ways of doing things that can then be utilized by data scientists, for instance. So there's that, I'd say, symbiotic relationship between the two, and there's potential in both areas. It basically depends on where an individual's interests lie.
All right, so be it AI or data science, so just find out more from us, from our counselors, so that we'll be able to share with you with more information about that. Right. So now it's time for us to wrap up our session today. I'm so grateful for your time, Dr. Imran, and I hope that everyone who is tuning in find this session is interesting. And we are gonna have the next session with the topic of Doctor of Business and Administration, BBA at APU. So stay tuned and follow our Facebook page. Thank you, everyone.
Okay, thank you.